Hi, I'm Sean Ganna, and this is Minute Math. And we have an interesting problem here. We're given this figure, and we want to find the value of MN, the length of line segment MN. What do we have in our figure here? We have a square ABCD that's given. We know that line segment DM is parallel to NB, as well as AM is parallel to NC. We're given some side lengths here that NB is equal to the square root of 2 and NC is equal to the square root of 8. So again, pause this video, see if you can find out the length of MN here, and we're gonna go dive on in and show you what the answer is here, okay? How to find it. All right, first thing I want to do here is I'm gonna extend the line segments NB as well as DM. I'm gonna extend those out. So extending these out here, extend that out here, right there, and extend this here. A nice little green color. By extending them out here, I'm gonna put some points. I'm gonna call this P and this part here Q. Now, these actually make some right angles. We're extending, right? We're extending this out here. It'd be a right angle on the inside here. This right angle right here, extend it out. These two, we have lines that are parallel, and we have lines parallel this way. These corners will also be right angles, and this is gonna be important for us. These right angles create a lot of right triangles. We can see that here. Little right triangle here, right triangle here, right there. The inside, right angle here. And then inside here, inside there. We got a lot of right triangles here. And we know about right triangles is their other two sides are what we call complementary angles, okay? So if I call this one right here, QAB, to be alpha, then its complementary angle will be beta. We'll call it beta here, all right? So all the ones here, whatever alpha is and beta, together they add up to be 90 degrees inside of that triangle here. Well then, if this is alpha and this big angle DAB is also 90 degrees, then this angle DAM is beta as well, to keep it in line. So then we have an alpha here. We keep repeating that beta. This is gonna be an alpha, this is gonna be a beta, and this is gonna be an alpha. Okay, so now we have a lot of angles that are actually congruent within this shape. And then how does this help us? Well, since we have a square, all the side lengths are the same. They're all congruent here. And if we look at how the angles work, we have angle, side, angle being congruent throughout all this shape here. That means every single triangle is congruent that has that same beta, side length, alpha. So each one of our triangles are congruent, meaning their side lengths have the same length, and we can really toss in some information that we know here, okay? We know the two legs of the triangle. So fill in what we have. We have a square root of 2 here, we have square root of 2. This will be square root of 2 right here, and this little length here, and then this little length here is the square root of 2. Then we also know the other leg of each triangle is the square root of 8, which is equal to 2 square root of 2. Double check that, and I'm good. 2 square root 2. So with that, every other leg, the long leg, is a 2 square root of 2. Now what happens if I want to find the length here of NP? Well, the length of NP is equal to the length of NC minus the length of PC. So NP, we don't know what that is. NP has the length of NC, which is 2 square root of 2, minus PC, which is a square root of 2, which then comes out to be NP has a length of just square root of 2. So the length of NP is a square root of 2 right here. Again, not drawn to scale here, but bear with me. We have a length of square root of 2. We can apply that similarly to length of MP, which is a square root of 2 as well. From there we have two sides of a right triangle. We can find the hypotenuse here using good old Pythagorean theorem. So a squared plus a b squared equals a c squared Square root of 2, the first one, all squared, plus b squared, square root of 2 squared, gives us c squared, which is the length of mm. And we go out. Square root of 2 squared is a 2, plus square root of 2 squared is a 2, equals c squared. 2 plus 2 is 4. We square root both sides, and c is equal square root of 4, which is 2, which is the length of mn, which we needed to find, which is 2. So after all of that work, we got an mn length of 2 right there. I hope you learned something in this video and you had fun with this problem. If you did, make sure to like this video, subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So, as always here, thanks for watching.